it's nice to see that you're in Dr. Mike's lab, where all the magic happens. And we're here to talk today about the Aquanox A4382. It's a new cleaning chemistry for removing organic acid fluxes.
Exactly. And, I'm standing here amidst, amidst an array of cleaning machines, some of which are familiar and others not. If we were to pan around, which we won't, we're going to stay static here. Mm-hmm. And the whole idea is you're right. This is where the proof is in the pudding. Our lab folks are at the other end of the building doing their design work, but here's where we identify the dilemmas and try to rectify them. Of course, in the case of organic acids, are more popularly known as water solubles. What they've been done, and you and Mike were just talking about it, from the automotive perspective, that, when electronics fail now, it's a stop as opposed to the radio not working. And, well, in water soluble, we've been done in by our densities. We've been done in by the board designs. As you know, I'm shooting this off my new iPhone. Mm-hmm. I'm sure Mike did before me, but I finally got a new iPhone. And because Mike is always, he's like the day before the rest of the world on stuff like that. We all know this to be true.
I know. Yeah.
So, and notice he's not denying it because we know it's true, right? But
I can't deny it.
And I am like years behind the power curve on this stuff usually. But think of the density of what's going on there. Think of the designs in this iPhone that are different from the first iPhone that was now 10 or 12 years ago, or the one I was using for the last 5 or 6 years. Well, as everything gets denser, things get tighter. The idea of water all by itself at 72 dynes, reaching into all those crevices, getting in, getting back out, regardless of the mechanical energy that's there to help, at some point the hole is just a little too small. And so bringing in some cleaning agents that can help that as well, help with that penetration, as well as have a better affinity, better rinsing, all this kind of stuff, really improve the overall nature of the process, and do so very economically and improve that reliability is really a key factor. And so that's where the Aquanox A4382, that's what drove that. We've seen that off and on for years. Your leading edge people over the years, they're the people that push the designs. They're the people that have the problems first. You work with them, that solves it, and then all of a sudden, the mere mortals, the regular folks are doing the same challenges, and thereupon now you have some actual market demand for that stuff.
So you answered my first question, which is why do we need it? And you've always answered that quite well. So how effective is it then at removing some of these flux residues? How much more effective is it?
Oh, tremendous. And remember, organic acids by design are water soluble. So if you take a drop of it and you put it in a Petri dish, it's going to go into solution. Okay, so now of course you can overheat things and cause unkind things to happen, but fundamentally you've got a good match there. The dilemma you have is what happens under that 1 mil gap when that water soluble flux, which is designed like all fluxes, they have very low surface tensions. They love to penetrate places. That's their job. Their job is to coat all surfaces and remove those oxides so we get a great metallurgical bond when we're soldering. Well, they also played out on the surfaces in and around all those components and get into very difficult crannies. And that's the key. The aid that the product really brings is bringing not only its cleaning action, but its penetrating action to get that stuff and remove it, absorb through one means and another to those fluxes, and then be able to be, the spy movie, it would be exfiltrate, right? To get back out again, so that the surfaces left behind are cleaned and then dried, as part of the whole normal cleaning process.
Mike, did you have a question? You had something you were going to ask.
Yeah. Hi, Tom. It's good to see you. Too bad we're not quite face to face and in each other's booths, but this is as close as we're going to get this year, I guess. KYZEN is a pretty active engineering company when it comes to engineering out new chemicals, and I'm wondering what drives the last year there was a chemical introduced by KYZEN. This year there's a chemical introduced by KYZEN. What drives that? Is that driven by your customer? Is that driven by a new flux formulation that is just incredibly more difficult to remove? Is that driven by environmental concerns or mandates, or all of the above? What's the primary driver for you guys sitting around going, we have a pretty successful company, we have a lot of great products, let's do another one? What's the driver there?
Well, it depends on your time horizon. In any given couple of months or a couple of quarters, any one of those is typically the driver. As I look back over the many years that we both have been in the industry, it's really all of those things, okay? Because, if we look back to the very beginning, KYZEN was founded because the governments banned ozone depleting products that were destroying the ozone layer over the Antarctic. That was the reason that our company was founded. Okay, so that was a regulatory trigger. When no cleans came along back now 20 plus years ago, well, it turns out that no clean was a bit of a stretch because a lot of people wanted to clean them and continue to clean them, as many people know. Well, in the beginning, they were pretty hard to clean. So that new category of soldering materials drove a long string of innovation to be able to succeed in that environment. But mostly what we do is we're deeply engaged with our customers, and our customers are not only the people inventing tomorrow, literally, right? That's our industry. Our industry invents tomorrow. But our customers in particular tend to be the people that are way at the edge of tomorrow, dawn's early light kind of folks on the technology curve. So they encounter those challenges first. And we believe that's on that particular day, of course, it's a bit of a challenge because maybe we're not answering the mail. But we see that as a great opportunity to get going on those developments early because, there's an old saying that, innovation's not cooking a cake, right? It doesn't come out of a can. You've got stuff to do. It's work to get there. And sometimes that work takes months or even years. We've had products that have taken years to develop to achieve the standards we were shooting for. So that early warning really lets us go, but that customer engagement is key for us. That's probably the most routine trigger where they're trying to do something innovative and a little bit different than the average assembly shop. We look at it and say, well, gee, maybe in 2 or 3 years everybody will do it. We'll be ready, and we sort it out, which is separate from the random shocks of regulatory things tend to come every once in a great while as a little bit more of a lightning bolt. Yesterday it wasn't true, but today it's true, and there's a big flash after this stuff. Sometimes innovation on the hardware side, that's your life, and as you well know, you guys also work on it, developing technology, advancing your products, and innovating. And sometimes those innovations make life better for the cleaning materials folks, and sometimes they create some challenges that we're the trade-off a little bit. And so we grin and bear it and kind of sort through that. But those two are more like that regulatory thing. They tend to come in clumps. The average and the steady improvements that we're working on a constant basis across a very broad product line, are that customer driven. Because remember, whether it's batch cleaning, or inline cleaning, or rework, or specialty things, stencil cleaning, there's an array of different application-specific products that are all on their own evolutionary cycles.
Yeah. Now, there's a lot of new regulations in that coming down the pipe as well, from Europe and different places. And there's always a lot of new flux chemistries coming onto the market that are getting harder to remove. And you've got a fairly unique system there at KYZEN for being able to deal with that when a customer comes into your lab. You've actually got almost like a library of boards on one of the walls in your lab there that has got.
We do. Absolutely. Yeah. And we have several refrigerators full of solder paste.
Right. So you can short circuit the process by, here's one I made earlier, but then we can add some of the bits, to emulate the process you're trying to clean. It's quite a unique system, and very good.
Very much. Well, we've always done that. We've got a big database, an old database that's been around for a long time. It's actually in an upgrade phase at this point, where we track all those different formulations because, you don't get it right the first time. There's a lot of trial and error. There's a lot of, some range of different combinations will probably work. Let's test them all and see which ones show most promise. We were able to compare different raw materials and how they behaved in the past. There's a lot of analytics. Sometimes it's actually chemical lab analytics. Sometimes it's just looking at the data and the result. It's just, all right, what's the right path? And we were fortunate in that we started very detailed, dedicated collection of that data a really long time ago. So we've got this great archive that's readily accessible for review and contrast. And that wall of boards still exists here. And when customers come and visit, of course, during the last year, that's been pretty infrequent. You know, they find a toolbox here in our we call it the demo room, even though we don't really sell any of the stuff that's, you know, that you can knock on that's sitting here. But it's an array of tools so you can sort it out, whether that's you do the testing and well wait, let's take a look at this. Oh, well, let's go shoot it on a high power scope or small enough. Let's see if we can, you know, when we're working in the packaging world, we do a lot of SEM analysis because we've got that scanning electron microscope. We've also collected all those tools over the years. And when they're immediately at hand, you know, that's a great luxury on that day when you really want to know right away, when you could just run over there and get that answer in a few minutes rather than sending it out to the lab and getting some information later. It really helps speed that up. And that's what brings all our product development together. That being able to use those resources to answer things, because, you know, when you're experimenting, by definition, you don't really know the outcome. You have to sort of listen to the data, see those results, process it, understand the variables that you've hopefully isolated well so you can get that understanding rapidly. And that's what turns into these new products that are, I mean, at any one time, we've got many products under development, and, you know, they come out when they're done.
Oh, sorry. Excuse me. There's a phone going off. Apologies for that. There you go.
Put $1 in the jar, Trevor. $1 in the jar. We're going to make a fortune.
At least, or
I know.
during.
I wish I, you know, the number of times I do things like that. Tom, going back to the Aquanox A4382, just what sort of concentration are you having to use with it? And does it concentrate? I'm assuming it differs between batch and inline.
Well, not so much between batch and inline. It tends to run quite low because, again, the nature of this thing is these are the water-soluble fluxes, the organic acid fluxes, are things that like to dissolve. You know, unlike when we're trying to clean a no-clean, where the no-cleans are kind of designed to not dissolve, right, for the most part, to be a bit impervious. So they tend to run at low concentrations. Of course, you have to be able to measure it so you know you have something. It turns out just sitting a pail or a barrel of our product next to the machine doesn't help. You have to actually get it from that package into the machine, although we've had a few customers try otherwise over the years. So typically down in that 5% or so range, pretty low. It varies by the design and the flux a little bit. And the process conditions. You know, some people tend to run very hot process conditions that can increase the challenge a little bit. And those are things that our team, you know, gets out there. It's not, you know, most people actually run this even a little bit below 5, down around 3 sometimes. So it's that whole idea of a little bit goes a long way, which back to the reliability and the benefits for the customer, you know, people are used to using just water, and just water, of course, is only one cost. Having a material in there is a second cost. You know, but you know, that 3 to 5% range, you're in pretty good shape there, and you're not going to really adversely affect your issue.
Tom, are our friends at AQMD and God forbid SCAQMD happy with this new material?
Well, every year 3 to 5%, they're pretty much always happy. Okay.
Yeah. Right. Right.
You know, they tend to like 25 grams per liter, which is around 3%, right? So, you know, most of these products are not 100% solids, unlike some other products. So yeah, they're the kind of people that are very happy with this. And let's face it, as we both know, Mike, if you can make the South Coast folks happy with your product, the world will pretty much be happy with your product. From a DOC
I've said many times that the South Coast Air Quality Management District, which is, you know, basically like the AQMD with a calculator with 3 buttons on it, and the buttons are divide by 2 equals. So whatever the feds come up with, these guys just go, okay, 50? No, we're 25. If the feds go to 25, we'll be 12.5. That's pretty much their job.
And they have done that for years. Now, of course, they're trying to keep people safe. And what most people don't know is that in California, what is it? I think there's 25 different air quality management districts.
Yeah, we have a lot.
Those being the most well-known. But you're right. I mean, they tend to be picky. But again, these are the sorts of materials that, frankly, are attractive. Water soluble can be attractive in Southern California because of those VOC regs, but designs are running away from it. And that's the challenge, because unlike a no clean or an old-fashioned rosin paste that some of the military people still run, if you leave some residue behind from a water soluble from a organic acid flux, the A is the critical word here, acid. We don't really want to leave residues on our circuit cards. That's almost universally considered an undesirable outcome. Right? Being kind here, and so. That's where materials being VOC compliant, really line up there and help those folks stay in California, stay local, compliant, but meet the reliability needs that these continuing to increase in density packages and whatnot are now the routine.
Well, I'm sure it's going to do really well for you. I want to thank you for finding your way to our platform today and telling us all about the new chemistry, and we look forward for sure to meeting you in person once we're all vaccinated and COVID free.
Yeah, thank you, Trevor, and I appreciate the opportunity. I have one question for our viewers or listeners. Do we need to invent a new word for what after virtual is going to be? Because I think personally I'm getting tired of new normal. Maybe you could run a survey, Trevor.
Yeah, exactly.
Can't be old normal, new normal. I don't like new normal. We need some other word. Maybe
hybrid seems to be a favorite word these days, But yeah, it's going to be interesting to see how it all pans out. But I think it's going to take quite a lot of time for everything to get back to the way it was.
I'm with it. I agree completely.
There you go. Anyway, thank you for joining us, Tom. It was great to see you, and we look forward to catching up again soon.
Will do. Thank you. Good to see you guys. Stay safe, and hope to see you again soon. Bye-bye.
Okay. Thanks, Tom. I'm here.
Global SMT and Packaging opens the windows of the world to bring you the latest news and technologies from Munich, from Bangalore, from Shanghai, from San Diego.